Hi, this is Tarik Rashid. This is second class or part 2 on Artificial Liver Classifier. The first part was the introduction about liver classifier or ALC. And the second part, it will be a practical example tutorial on how to implement the ALC and how to compare it with multi-layer perceptron. So for example, if we have an input matrix or input pattern, 1, 2, 3, 4, and we have a weight matrix, for example, 5, 6, 7, 8, 9, 10. This is in multi-layer classifier, multi-layer perceptron, we call weight matrix, and in ALC we call cofactor. Okay, so bias calculation would be in ALC would be in this way. Sum of the all elements in cofactor over total number of elements. So that's how we are working out with this one. So 5, 6, 7, 8, 9, 10, sum of them and divided by 6, you will have a bias matrix in ALC. That's how you compute the cofactor. Now, the given equation is computed using element-wise multiplication of x and each column of cofactor, followed by row-wise mean calculation and addition of the bias term. So here, A, i's column, how to get this matrix. For i's column, it equals mean x input multiplied by weight for i's column matrix. I for i's column for weight matrix, and also finding row mean here plus the mean of the weight matrix or cofactors. So this is the example that we have. The first phase, which is lobule, first column of cofactor, x multiplied by cofactor for the first column. Okay, so for the first column would be 1 times 5, 2 times 5, 3 times 8, and 4 times 8. So if we go back to the 1 times 5, 2 times 5, and 3 times 8, and 4 times 8. So that's how we found it, and we will get results for them. And then mean along axis 1, it will be the mean of 5 and 10, that will be 7.5, and the mean for 24 and 32, it will be 28. So that is how we are going to, so that's the mean 5, 10. When we say mean along axis, that means mean for the row and mean for the second row, 28. So that's how we did it. So first layer or first lobule in ALC, output would be matrix A, 7.528. Now, for the lobule 2, second column of the cofactor, 6, 9. So x times cofactor, second column, 1 times 6, 2 times 6, 3 times 9, 4 times 9, and that's the results. And the mean 6 and 12, 9, and the mean 27 and 36, 31.5. That is the lobule second output. And then for the lobule 3, third column of cofactor, which is 7, and 10, that's the weight cofactor. So input 1 times 7 and 2 times 7, 3 times 10 and 4 times 10. That is how we call it. And then we find the uh, along x1, axis 1, that means we take the rows, mean. If it's 0, we take the mean for the column, by the way. If it is along axis 0, it is column mean will be taken, but now we take row mean. So thus the lobule tree output becomes this much, and that's your output in ALC. That's the output matrix for ALC. Now, the same approach for other lobule can be done similar way. And if we are trying to add bias to it, so adding bias, we will have this matrix 5 plus 6 plus 7 plus 8 plus 9 plus 10 divided by 6. You'll have 7.5. So 7.5 adding to 7.5, it'll be 15. 7.5 adding to 28, it'll be 35.5. 7.5 plus 9, 16.9. 7.5 added to 31.5, 39. 7.5 added to 10.5, 18, and added to 35, 42.5. So this with the bias matrix, while this one without bias. This one without bias, and this with bias. So if we do this, the computation for multi-layer perceptron neural network without bias, this would be the formula. Hidden layer equals x multiplied by weight matrix. So input 1, 2 times this matrix, that's the output. So the H1 will be this much. Now we can do it for sample 2, 3 by 4. So 3 by 4 multiplied by the weight matrix, we will get this one. So now the MLP output matrix will be H21, 47, 24, 54, 27, 61. So this is complete, plus the bias, which we have it. It will be 21, 47, 24, 54, 27, 61. That is the output for the multi-layer perceptron. So with the bias will be this much. We're adding 7.5 to this matrix. So that's the results of MLP, which has a different calculation. ALC has a simpler calculation operation. Now, the differences between ALC and MLP, mathematical-wise, ALC uses a linear combination of input features weighted by a cofactor matrix. Okay. MLP also uses a linear transformation, matrix multiplication between input matrix and the weight matrix. Okay. And model complexity, ALC is more like a linear model that combines weighted inputs and averages them. MLP is a nonlinear model. Use cases, ALC is suited for simple linear relationship using weighted averaging. MLP handle more complex nonlinear patterns. Again, we talked about this. So ALC uses cofactor sums, but MLP uses nonlinear multilayer using hidden layer activation functions, ReLU and softmax. ALC, it is a liver classification machine learning algorithm using cofactors. MLP, it was inspired from the human brain as a biological neural network, but time complexity, this is the time complexity for LC, big O n plus FP, and then MLP slower, back propagation, they use back, we use optimizer iFox, and space stores cofactor matrix small, stores weight biases for all layers, which is large. So this is simple, works with small data sets, and this is complex architecture. And it has a risk of overfitting. And it has also a problem of early stopping. So more or less, these are the differences between the two machine learning techniques. We advise you to use ALC as a new machine learning classifier, and very simple. And it can be used for unlimited application, and it can also be modified easily. So more comparison between the two. This is ALC. This is MLP, and you can see the difference between them. Here, more core differences in terms of equation. You can see how they are different from each other. And we explained all this in the previous slides. So thank you so much, and stay tuned for the next presentation or class.